this video, I'm going to demonstrate how to titrate an approximately 0.1 molar hydrochloric acid solution with an approximately 0.1 molar sodium hydroxide solution. In this case, we will not assume that the sodium hydroxide solution is exactly 0.1 molar. It is whatever concentration we determined at the end of our standardizing experiment. Because every time we make a sodium hydroxide solution, the first step is always standardize it with KHB. Once you determine through that experiment what the actual concentration of the sodium hydroxide solution is, after that, you will use that number for all subsequent experiments. So for today's experiment, I will be using that same sodium hydroxide solution, which is approximately 0.1 molar, but not exactly that. For today's experiment, we're going to need a burette that is fully charged with our titrant, which is the approximately 0.1 molar sodium hydroxide solution. The burette will be supported by a burette clamp, which is tightly connected to a stand. Additionally, we're going to need another clamp. This is going to be used to hold our pH probe in place. And with that, we need a pH probe. We're going to use our wireless vernier pH probe. It has to be used after it went through the two-step calibration process. We are also going to use magnetic stirring, so we need a stir station. In between measurements or transfer between the buffer to the titration vessel, we will need to rinse our pH probe with some deionized water, and whatever falls off of there will need to be connected into a waste container. For our solutions, we're going to use our 0.1 molar hydrochloric acid solution that we originally prepared. And there are a couple ways in which we can transfer that into our 150 milliliter beaker that will contain a magnetic stir bar. I have a couple little ones here. I just need one of them. I will use a little red one. And to measure out the approximately 25 milliliters of 0.1 molar hydrochloric acid, I can use either a large pipette that has the 25 milliliters marked on it, or I can use a 50 milliliter graduated cylinder that will allow me to measure the approximately 25 milliliters. I will use an indicator for this experiment, and today that will be the universal indicator because it has a variety of colors as the pH rises from 1 to approximately 13. And in order to fill up our burette with additional solution, we're going to add more sodium hydroxide for subsequent titrations. And for that, we're going to use more of our sodium hydroxide solution and a secondary container that allows for easy transfers. What will this look like before we can even begin the titration? Well, let's get started on the setup. The first thing that we're going to do is make sure that everything is in the right place. First, we're going to bring in our stand, and we're going to position our burette so that it will be above the beaker that has the stirring rod. We will turn on the stirring to at least medium-high to identify the location of the stirring rod as it is going to mix our solution. This is important because we don't want the stirring rod's rotation to accidentally hit the very sensitive pH probe. So if it mostly stays in that position, our pH probe has to be somewhere else inside our beaker. And with that, we can turn this off and we can prepare for the insertion of our pH probe. The first thing is we approximate the position of our pH probe and we bring our clamp in. The position of the clamps should not interfere with the rotation of the stopcock that is attached to the burette. So that means either positioning it above or below the stopcock for ease of handling. Then we're going to take our pH probe slightly unscrew the cap of the container, extract it, rinse it with deionized water, wipe it with Kim wipes and not paper towels, and slide it in position, and then loosely close the clamp around it. At that point, once again, we check for the rotation of the magnetic stir bar and make sure it does not accidentally bump into the pH probe. Once that is done, we can turn it off. Next is the addition of our acid in our 150 milliliter beaker. I will be using a pipette. I will slide the extractor on top, bring in my hydrochloric acid solution, remove the cap, and I will set it aside this time because I will need both hands to carefully maneuver the extraction. I will slide it in so the tip of my pipette is below the neck of the volumetric flask, and I will slowly start dialing it up. On this pipette, there is only one marking, and when the hydrochloric acid solution will get to the mark, it will have the volume of exactly 25.0 milliliters. This should be done relatively quickly because the pH probe shouldn't be left in the air for too long. When the meniscus of my hydrochloric acid solution is at the marking, I will extract it from the volumetric flask, transfer it over inside the beaker, and then press the release and allow it to flow into the beaker. Once the transfer is complete, we can set our pipette to the side. Our pH probe is now connected, and it should stand relatively stable, and we can begin the stirring process. It is important to add enough hydrochloric acid to the beaker so that the bottom of the pH probe is fully submerged and it can give us accurate pH readings. With that, we can put the cap back on to the hydrochloric acid and set it aside. We're going to add a couple drops of indicator to our hydrochloric acid solution. 3 drops should be sufficient to get a fairly strong color. If not, we can add 1 more drop. If the surface on which we are conducting our titration is not pale, not exactly white, but pale, then it is best to slide a white paper under the beaker so that we can monitor for color changes more accurately. Before we can do anything else, it is important that we record our starting volume for the sodium hydroxide and the starting pH of our hydrochloric acid solution. Since we connected our wireless pH probe to my iPad, we're going to monitor any pH changes through the iPad. So at this starting point of the titration, our pH is 1.12. Our starting volume of the sodium hydroxide solution, we need to record. And to do that, I need to bring it much, much closer. It may be easier for me to just transfer it to the other side. Move the station to the edge of the bench top. Place our burette inside again and slide it down to eye level. My starting volume is 0.37 milliliters. And just like every other time, I am not going to adjust myself to the burette. I am adjusting the burette to myself. When I'm ready, I will transfer it back to the other side. Place it in fixed position. and then slide it back so the tip of the burette can be above my beaker. And then slide it back just a little bit. The addition of the sodium hydroxide solution will first go in approximately 3 milliliter increments, and then it will slow down to 2, 1, and then dropwise. All of that will be dictated by the changes in the pH. When we are close to the equivalence point, our pH is going to rapidly rise. So as soon as we start seeing a change or a substantial change in the pH, we need to slow down our additions to dropwise, and then stop after every addition of a drop, record the pH, record the volume, and do this until we exceed the equivalence point. After that, we're going to continue adding more sodium hydroxide until the final pH gets in the range of 12 or 13 and stays there for at least 3 measurements. So let's get started with our titration, and hopefully it will result in some lovely color changes and a successful S-curve graphing. We have our starting volume of the sodium hydroxide. We have our starting pH of 1.13. Let's add approximately 3 milliliters in the first addition. I added approximately 3 milliliters, and I will record the exact volume according to the burette, and I will record the pH. So the pH is a 1.20. The volume, which I can read more easily now, is 3.41 milliliters. We're going to add approximately 3 more milliliters. Give it a second for the pH to settle. The pH is a 1.28. And our volume for the sodium hydroxide is 6.52 milliliters. We add another 3 milliliters or so. The pH is a 1.36, and our volume, now it's a little bit easier to read, 9.40. I will add another 3 milliliters. And notice the color of the solution is still pink, pink-orange. My new pH is 1.47, and my new volume is 12.69. The color of the solution is turning more towards orange, so this is a good place to slow down. Our new volume of sodium hydroxide solution added is 25.41 milliliters, and our new pH is 2.9. This is where it may go a little faster with the pH increase, and we need to slow down with the addition of the sodium hydroxide solution. The pH rose above 3. The new volume is 25.78 milliliters, and the pH is 3.30. The pH at this step is 6.64, and we can add another drop. The new volume of sodium hydroxide is 26.20 milliliters. And the new pH is still increasing. It is very close to 8. The pH is now settled at 9.11. And we can add another drop of the sodium hydroxide solution. The solution is now a magenta colored. The pH is rising quite rapidly. Our new volume is 26.34 milliliters. And our new pH is 9.69. We can add another drop or a couple drops. The new volume is 26.48, and the new pH is still climbing, but settling at 10.29. Now we can increase the increments of sodium hydroxide. I added approximately a milliliter, and my new volume is 27.50 with a pH of 11.29. I can increase the increments of sodium hydroxide now. My new volume is 41.32 milliliters, and the pH is 12.27. Because we have at least 3 measurements in the close vicinity of 12 or above, we can consider our S-curve data set collected. And now we are ready to do this titration again at least 2 more times. And in between each titration, we're going to clean and dry our beaker, clean and dry our magnetic stir bar, fill the burette with our titrant, and rinse our pH probe with the deionized water, and then wipe it with the Kim wipes. You can do the titration of a strong acid and strong base with the base as your titrant, or you can do it the opposite way, where you start with the base in your beaker and your acid in the burette. Both will work the same way. The only difference that you'll have is that when you're titrating with an acid, your pH is going to drop instead of rise.